In this next set of videos, we're going to introduce the idea of polar coordinates. So the polar coordinates are a different way to express points. It's a little bit different than the rectangular plane, but you'll see some similarities. You will see a point format here. There's Griffin saying hi. Instead of using X and Y, we use R and an angle theta. And I have an example. All right, I'm going to pause and I'll be back in a second. All right, so just a different way to write coordinates. Again, a different kind of graphing system here. So what we're going to see is R represents a directed distance from what we call the pole. The pole, you can kind of think of like an origin in a way, right? It's like a starting point. And we say directed distance because R, it's not quite a radius like we're used to, or an exact length. It actually can be positive or negative. So we'll see that in a second. But the R does have to do with how far out along this segment you go. Your pole is like your starting point. It's like your origin in a way. And then a horizontal line coming out from that is your polar axis. So that's kind of like an x-axis. It relates very similarly. And then what happens here is you have an angle theta that creates a segment. And you have this point out here. And what happens is that R relates to how many units along the segment you are out. So for example, let's say our polar coordinate was 3, pi over 4. So we have our pole, we have our polar axis here, and then this is our angle. Angles can be positive and negative like they have been. So if it's positive, we move in a counterclockwise direction. If they're negative, you would go downward, right, in a clockwise direction. So here's positive pi over 4. I just did my best to estimate that angle there. And then my value was 3. So what happens is when we create that segment or that ray coming out from the pole there, our point is 3 units up. So that's where that 3 comes into play. Again, 3 is positive here, so it follows along the axis. We're actually going to see that when 3 is negative, it actually bops down and sort of goes opposite to what the axis is. So let me make that note here and write it in a way that hopefully is clear to understand. All right. Okay, so let's write this more formally now. So we have that the point P, which is R comma theta, is located absolute value of R units from the pole. And you can see that here. So we're just going out 1, 2, 3 units there. If R is positive, the point lies on the terminal side of theta, which is what we have here. If R is negative, though, what happens is the point lies on the ray opposite the terminal side of theta. So for instance, just using the same example we have here, if our point instead was negative 3 pi over 4, so I would have, again, here's my pole. Here's that same angle, theta, which is pi over 4. And then what happens is you take the ray opposite it. So I would continue that ray in this direction. And instead of going 1, 2, 3 units up here, I would go 1, 2, 3 units down here. So it would look like that. The last case is if R is 0, then the point lies at the pole. Regardless of theta. So it doesn't matter what theta is. If r is 0, then you're right on the pole. It doesn't matter what theta is in that case. So that's the more formal definition here. And I think it's going to help to see a few more examples. So we're going to plot the points of the following polar coordinates. All right, so the first one's going to be 135 degrees. So again, I'm going to start by drawing my pole and bring out my axis here. And then I'm going to calculate 135 degrees first. Now, if it helps to put the other axes in, you can kind of do that lightly. Maybe I'll do that in purple, right? So, here's your kind of main axes here. And if you think about it, well, 90 degrees would be, 1/4 turn. 180 would be a half turn. So that's too far. 135 degrees is 90 degrees plus 45. So we're coming out at an angle like this. Right, so this is my theta. And again, it's positive, so we're going in the positive direction. Now, where is our point? Well, it's 2 units out. So I have 1, I have 2. Let's use a different color here. And this is going to be my point. Now, when we do 2 units out, those actually make full circles all the way around. Not really great at drawing circles, but I'll do my best. So it's like 1 unit out kind of goes like this, and then you have 2 units out like this. And then if you had 3 units out, it would be like this and so on. So you just kind of go out, usually you're at a diagonal, so it looks a little bit different, but you're just counting out those diagonal units, and they're circular here in our polar coordinates. All right, our next one is -3 pi over 2. So again, I'm going to start by putting in that pole first in my initial ray, and then I'm going to go ahead and find this angle here. And again, it can help to draw things out a little bit more clearly. Now we're going back to radians. So if you think about radians, 3 pi over 2, well, pi over 2 would be 90 degrees, and then you have pi is 180. And then 3 pi over 2 actually gets you the full 270 degrees around. So this is going to be our ray on this side, and this is actually our angle here. Now we're looking at a -3. So you do want to be careful. Because the 3 is negative, we're not going to be on this side of the ray. We're going to go opposite that side. So we're actually coming up here instead. Again, because you have that negative, and we're going 3 units. So we'll use the lines here, 1, 2, 3. So my point would actually be right here. All right, and let's do one more. So again, I'm just going to go ahead and draw my axes in. All right, now -pi over 4. So you're going in the negative direction. You're going to go clockwise instead. Pi over 4 is 45 degrees. So our angle comes down this way. But because you have a negative here, we're actually going to the ray opposite it. So I'm just going to continue that ray this way. And then we're going out 1 unit. So instead of going 1 unit here, I'm going to go 1 unit here. So my point is going to go right there. And this is my point. All right, so that's how we can plot points in the polar coordinate system. Now, one thing to keep in mind as well is that remember with angles, you have this period here of 2 pi in the sense that like, you know, if you have the unit circle as you go around, it repeats every 2 pi. So it's possible to actually write the same point in many different ways, which gets really kind of tricky sometimes, right? Like this point right here, for instance, we also could have written as like if we go around this angle twice, right? Instead, we could take this and go around a second time. So do this plus 2 pi, for instance, right? And you would get back to the same, that same terminal side here. So that comes into play here as well. So let me make a note here. So if n is any integer, the point r theta can be represented as r theta equals r theta plus 2 pi n or 2n pi, or even r theta equals negative r theta plus pi plus 2 pi n as well. So if your r is negative there, you can go ahead and add a pi to that and get the same value back for the angle. And then again, you have that 2 pi circular idea that keeps repeating over and over again. So you can get the same points, again, using different formats here. So let's go ahead and do an example of that. So the point 2 pi over 3 is plotted. I'm going to draw the picture for you in a second. And what we're going to do is find other representations of it. So in the first case, we're going to let r be positive and theta be between 2 pi and 4 pi. In the second case, we're going to let r be negative and 0, theta between 0 and 2 pi. And in the third case, we're going to let r be positive again. And this time, let our angle be between negative 2 pi and 0. Now I'm using symbols here for positive and negative. Sometimes it will actually write the words positive or negative. And of course, that is fine too. So the first thing I do want to do here is I am going to go ahead and just draw this picture first. Maybe we'll do it right here. So I'm looking for pi over 3. So that's going to be about here. It's less than pi over 2, so it's less than 90 degrees. So I'm not going to go all the way full up. And then our unit is 2 there, our value is 2. So we're going 2 units out. So we'll just do 1, 2. And we'll do this point right here. Again, I'm just approximating my picture, right? So I'm just doing my best to be consistent as much as I can and get, approximately the right looking angle in this case. So for A, I do want r to stay positive, so I'm going to keep going in that positive counterclockwise direction, but I do want theta to be between 2 pi and 4 pi, so I want it to be a lot bigger. And what I can do is I can use that idea that, if r is positive, I can add 2 pi n to it. So n could be 0, 1, 2, 3, 4, etc. So I can add 2 pi as many times as I want to it, and I will still get a comparable point. So here what I'm going to do is I'm going to take that theta over that theta, which is pi over 3, and I'm going to just add 1, 2 pi to it. So that would be 6 pi over 3, and then when I add, I get 7 pi over 3 there. So all that's going to do is it's going to take that same angle and just go around an extra time. So it's going to go around 1 whole 2 pi and then come back to the same landing spot. And again, we're still going in the positive direction. That 2 is not changing. So my new point is 2, 7 pi over 3. I shouldn't say it's a new point, it's just a new representation. It's the same exact point on the graph here. Okay. Now for B, we do want to have a negative value here for our R, and it's going to be the same idea. You're not going to change the number. It's going to stay 2, it's just going to be negative. So that's going to be one thing that we're going to change. And in this case, I'm going to use my second form here. So going from R theta, I can make the R negative, and I can do that by adding 2 pi to it, or sorry, by adding pi to it, excuse me, and then I can also add additional 2 pi's to it if I want or if I need to. So for this one here, we want to be between 0 and 2 pi. So I don't want to add extra 2 pi's. I'm just going to add that initial pi value to it. So let me do that first. So I have pi over 3. I'm going to add pi. So that becomes 3 pi over 3 to get common denominators, or pi over 3. So what happens here is that point 2 pi over 3, 2 comma pi over 3 becomes negative 2 comma 4 pi over 3. It's going to be the same exact point once all is said and done. But again, I'm using that second way that we can tweak those points. So R theta becomes the negative of the R, whatever the original R is, the negative of it. And then we can also add pi. And then again, if you want to add more circles around that 2 pi, you can. And just check, right? 4 pi over 3 is between 0 and 2 pi. 7 pi over 3 is between 2 pi and 4 pi. So they are fitting the requirements that we have here. All right, let me do the last one. So the last one, we do want our R to be greater than 0. So we're going to stay in that positive direction here. But we want our theta to be negative, between negative 2 pi and 0. So what I can do there is I can actually just subtract with 2 pi. Now this is okay. So you're maybe saying, well, can't we just add with 2 pi? But n could be any integer, so n could be negative. If n was -1, that would be the same as subtracting with 2 pi. So that's what I'm doing here. I'm just letting the R be negative, and instead of adding the 2 pi, I'm just subtracting it. So it's using negative n's instead. And I get negative 5 pi over 3 here. Now that is between 0 and negative 2 pi, so that's fine. And then my R remains positive. So 2 pi over 3 can also be written as 2 negative 5 pi over 3 in the polar form.